Hello everybody, I am Professor Dr. A.K.M. Head Department of Electronics and Telecommunication Engineering, Daffodil International University. Welcome all of you here from this course Computer Networks. Today I am going to talk about the sessions on routing protocols. From this lesson we will be able to know about the different routing protocols and why do you need routing, what is the necessity of routing, what is the functionality of routing. I will hope that you will have good concentration in this lesson. First, I'd like to introduce you what is actually routing. You know, the computer networks router is used here, and the topology it is needed to discover the remote networks. So normally if the networks of routers, there are some hands and this network is called connected networks, but if there are some networks via routers, so this actually networks is called remote networks. So if we want to discover the remote networks, normally it is not possible to find out this network. So in this regard we need routings. So that means in the topology there are many networks, some networks are connected networks, some networks are remote networks. So if we want to find out the remote networks, we have to make routing. So based on this, routing is very important. If you want to make the routing, so router, there are some routing tables, router have some tables, and if the destination host networks is matched with the routing table networks, then the only packet can be forwarded to particular workstations or particular host. So there are some protocols here. One is this is routed protocols and another one is routing protocols. So first we have to understand what is routed protocols. Routed protocols, that means the IP in layer 3 protocols. These protocols allows the host to send the information from source to destination with a specific ID, that means IP. So IP actually, suppose as for VoIP, that means voice over IP. Voice is being transmitted over IP. IP is the responsible to carry the information from source to destination. So only these responsibilities. This is a routed protocols, and it has some must have some network with a suppose IP or IPX addresses, logical addresses. And routing routed protocols, it's IP actually, and in this figure if we see the frame structure, packet structure here, there are some version, how many bits belongs to this version, some header, then the type of service toss, total length here in the kilobit here in this figure you can see. Okay, so routed protocols versus routing protocols, very important here. We can have the good discussion here. Routing protocols, actually I explained routed protocols. Routing protocols, the function is we have here in this figure we can see the IP, IPX or something, and routing protocols has the speciality to discover the remote networks. Also I will have the brief description later next time. There are two types of routings actually, one is static routing, one is dynamic routings. Particular routings can be used for these protocols. Suppose there are two types of routing protocols, one is distance vector routing protocols, one is link star routing protocols. We will also have brief description about this. If I say what is the routing protocols, what is the name of the routing protocols, we can say suppose RIP, routing information protocols, version 1 and version 2. Also we can see IGRP, enhanced interior gateway routing protocol. We can say OSPF, open shortest path first. We can say ISIS, intermediate service to intermediate service. Also there are some special protocols, suppose EGP, border gateway routing protocols. Okay, in the next slide or next part we will also see about these details about these protocols. Okay, so in the next slide we can have the comparison here the static versus dynamic protocols. So first we have to understand why do you need static routing, why do you need dynamic routing, and which purpose, which routing protocol should be used. Static means the path is predefined, that means administrator is saying that you should go, the package should be go this way. Why do you need static routing? The dynamic routing, there are multiple paths here. So first, the necessity of static routing. There are some also advantages or disadvantages, because static routings also only contains the information, router contains the information, only configured information, which way it is used. Administrator is saying from source to destination, from this router, this router, this router, information can go, you can configure manually. And if the destination network is one way, it is called stub network. If I say that the topology, the network is stub network, then static routing can be considered here, because there are no alternate ways. In this stub network, even if you use dynamic routing protocols, same way can be used. But my question is, if stub network, why I will use the distance vector routing protocol? Because if a distance vector routing protocol is installed in one router, lot of configuration can be installed. I need faster convergence, I need some additional time, high bandwidth. But if I make static routing here, so more other logistic supports is not needed here. So that's why in this topology static routing is evolved here, in static router is best. On the other hand, you can consider if we have multiple path, multiple way to go to find out the destination network or remote network. In this type, will we consider dynamic routing or static routing? This is the question. So in this type, in this time, you can consider dynamic routing, because if you are considering static here, one path, if there is some problem, if there is some link fails in this path, there is no alternate way, you can't go, you can't reach the destination network. So on the other hand, if we could establish the dynamic routing protocol, if one path is failed, there are some other alternate redundant paths. Using this path, you can consider, you can go to information, packet can be sent from other ways. That's why we have to understand which situation, which routing protocol can be used. Okay, thank you. In these types here, I think you have some good understanding from static and dynamic routing protocols. There are, in this slide, we have considered IGP and EGP. IGP actually it means interior gateway routing protocols, and EGP exterior gateway routing protocol. We have to think which routing protocols is considered for which purpose. IGP, suppose I have one network, it is autonomous system. This autonomous system has some lot of routers. So inside this autonomous system, this one routing protocol is considering for remote network. Suppose in this autonomous system, in this text here, suppose this autonomous system has 5 routers, there are sub 3 remote networks. It is also considering remote networks, but this protocol is used here, this is called interior gateway routing protocol, because this protocol is used in the same autonomous system. Okay. An exterior gateway routing protocol, I am trying to access one router to other networks through this outside of this autonomous system. So that means I have one autonomous system, I have different autonomous system, and if I want to access this information to other remote networks, I have to use one EGP, exterior gateway routing protocol. Which is this? BGP, border gateway routing protocol. So border gateway routing protocol is used to interconnect these two different autonomous systems. This is very speciality of these two routing protocols. Okay, so in this figure, IGP versus EGP, if you see this figure, there are some 2 different autonomous systems. One autonomous system RIP version 1, RIP version 2, EIGRP, OSPF can be considered. Also other autonomous system, the same routing can be considered. This RIP, EIGRP, OSPF in this figure can reach or can discover the remote network in same autonomous system. In the other figure also, these IGP protocols can be accessed in the same autonomous system. But the question is, if I want to access the first autonomous system to second autonomous system, what will be, who can do it? This EGP, external, that means in gateway routing protocol, and the example is BGP. BGP can communicate these two different autonomous system. Okay. Autonomous system, again and again we are saying, very frequently we are talking about autonomous system. Actually autonomous system, how can we define in computer network? Autonomous system means you can see from here that the same network, all sum of groups of routers or some routing protocols are maintained in a same manner, in same banner. This is autonomous system. If I say one university, 5 university of my country is following one rules nominated by University Grants Commission, they are autonomous system. Suppose some other universities in USA and Germany, they are following one rules, so they are autonomous system. So if we want to communicate these two autonomous system from US and Germany, from Bangladesh, so these border gateway routing protocols are being exchanged. That means this information is being exchanged through this external gateway routing protocol. So this informations sharing itself, this is the same boundary, this is autonomous system. And here in this figure, autonomous system, in this figure you can see it can be shared the information by some devices, switch, routers, workstations, hubs, or many networking devices can be shared in the autonomous system. And if we in this autonomous system, if there are some remote networks, must we have to install routing protocols. If we don't have the remote networks, it is not required to install routing protocols. Even in the autonomous system inside, if we think it is a stub network and other autonomous system is not a stub network. One side we can use static routing, one side we can use dynamic routing. Also these two routing we can communicate through the EGP, border gateway routing protocol. So autonomous system terminology, there are local traffic, transit traffic, service, multi-home days, and there are some parameters here. Based on these parameters, the terminology can be considered here. And the distance vector link state routing protocol, I will explain why it is called distance vector, because I have the topology. If I want to get the remote networks, I have one way, I have multiple way. So distance means how far, how many hops are considered here. How many hops can be calculated to reach the destination network. This is distance. Vector means one router, there are multiple interfaces. Suppose there is Ethernet interface, serial interface, other interfaces. So which interface is considered to forward the packet? This is vector. So that means maintaining this distance and vector to achieve the destination networks. Which protocol is considered? Distance vector routing protocol is considered. So what is distance vector routing protocol? This distance and vector is considered. How far and which interface is considered to forward the packets. This is distance vector protocol. Example of distance vector routing protocol, RIP, EIGRP, etc. You can say EIGRP, there is some debate here, not very big debate here. EIGRP itself distance vector routing protocol, but on the other routing protocols owner, they are saying this is hybrid of distance vector and link state routing protocols. So on the other hand, if I say the link state routing protocols Unlike distance vector routing protocol, the link state routing protocol has a good topology, topological map it has. There are big topology. Distance vector routing protocols, it is decided. There are a lot of paths. Suppose as per RIP, the metric is the minimum hop. If you give many bandwidth or some other loss, no, it's not necessarily. He will just count the minimum hop, which way he can goes from source to destination. But the minimum hop can be 1 or 2 or multiple. That means equal cost or balancing itself. But the OSPF, suppose link state routing protocol, highest bandwidth he is considering. He has the total roadmap he has, and based on this any time he can change the decision. He can have the best opportunity from here. All information he is looking here. So this is the fundamental difference between link state and distance vector routing protocol. Distance vector routing protocol and link state, in this figure you can see there are some drawbacks also. That means sometimes it has some topology, if some links fails and he has to think again, he has to recalculate informations. And also the distance link state routing protocols, there are some bandwidth is faster, convergence time faster here, some topology. Suppose RIP, convergence time slower. What is convergence time? That means if any changes, if any links fails in the topology, so it is needed to trace or it is needed to send the information inside the topology. So if it is not done, so the packet tracing or packet forwarding will be interrupted. So what do you think? It is called convergence. So when any change in the link, immediately all routers will be informed. After that, this router will delete this information, delete this network from his database. So now he is stable. So this is converged. So what do you think? Convergence time should be faster or slower? Of course, convergence time should be faster. So some distance vector routing protocol convergence time slower, but link state routing protocol convergence time faster, because if the convergence time not faster than others, so the packet timing, packet forwarding time will be also delayed. So it depends on the scalability of the network. Scalability, how scale you are considering. If the network size is very large, that means of course we have to think which distance vector or link state routing protocol will be considered. In this regard, link state routing protocol have the good performance. Scalability is large. In large scale, he can deal the total topology. So routing metrics here, very important here. There are a lot of metrics or lot of parameters to find out the destination networks. Minimum hop, if RIP is considered, minimum hop is considered. That means 15. If the hop number is more than 50, it is actually infinite. So if one router have the 16 hop networks in his database, he will not consider it. He will delete this database informations. Also metric bandwidth we can consider here, load, reliability, delay, throughput, many things here we can consider to reach the destination or to discover the network protocols. Discover, I am saying that in this sense, connected networks already discovered, because router, how many legs or how many hands are connected to other networks, the adjacent networks will come automatically, we discover automatically. But if the networks is so far from this host network, host router, then we have to think for routing. And if we want to do routing, if we want to access the information from the remote networks, we have to first find out the remote networks. So using routing, and which kind of parameters or which kind of metric can be used, this slide says. This, based on this figure, based on these parameters, you can find out the destination network or remote networks here. Routing metrics here, protocol type I says, the distance vector, link state and hybrid. The distance vector, there I said the RIP, EIGRP, also and the RIP has also versions 1 and 2, RIP version 1, RIP version 2, and there are some provisions here, there are some differences. We will have some short description also later, and the link state routing protocol, you can say OSPF and ISS, and hybrid actually I also little descriptions before, that means EIGRP is a Cisco routing protocols, and it says itself that it's a distance vector routing protocol, but it has some debates here. That means other owner they are saying actually that it is hybrid, because in the EIGRP there are distance vector or bandwidth. That's why you will think that some of the parts is just sharing the from distance vector, some of the part is sharing from the link state. That's why they are saying that is a hybrid of distance vector and link state routing protocol. So you say actually it's not our main concern, it's just the technological debate of based on this routing protocol. Administrative distance, this is also very important parameters, because it can be happen like that the destination or remote networks going through two different protocols. Suppose there is two boundaries, one is RIP is using here, one is EIGRP using here. These two different protocol boundaries using the packet can be sent. The question is which routing protocols will be preferable here. We can't send the information through these two different protocols. Our option is one. That's time this problem is solved by administrative distance. Administrative distance does prioritize the routing. Which routing should be preferable here? The thing is every routing has some values. Less values will get more priority. I will have some description later. Suppose connected networks administrative is 0, static 1, OSPF 110, then RIP 120, internal EIGRP 90. So if EIGRP and RIP is considered to reach the destination network, which routing should be preferable? Less value will get more priority. This is the speciality of administrative distance. Understanding routing table here, that means every router during the data transmission when routing protocol is used, every router makes the table, routing tables. That means all network information associated with this topology, there is some tables. The question is when one packet is going to forward to other networks, so the host network will first recognize the destination IP's network, and if it is matched with his network itself table, then only packet can be forwarded, otherwise not. So every router we know after a certain time, if it is periodic update or triggered update or some other update, partial update, bounded update, but updates can happen at a certain limit of time. All routers have the informations. So router just similarize the informations, router just memorize the information, it has provisions, and when packet is forwarded he will match the information itself, and if it is matched then it is forwarded. That's why it is required, it is needed to make the table, and router has this routing table. So I hope these chapters you will have the brief description of routing protocols, and also if you have the more knowledge you can have some textbook or some other places from the internet or some places you can also make some topologies from here using packet tracer, and using these commands or some other Cisco manuals you can type the commands using CLI commands, you can send the packets, you can find out the performance of the matrix. Okay, so I think we will have some next session, we will have meeting of different topics. Thank you today, see you later.